We have a continuous increasing function that is concave down on the closed interval from 1 to 5, and it's represented by this table. And so here I drew this function right here. So this is concave down. We want to write the midpoint Riemann sum that estimates the integral from 1 to 5 of f of x dx based on the subintervals given in the table. Because we're using the midpoint, we have to find the midpoint between each point. So starting off here, the midpoint between 0 and 0.788 is 0.394. Midpoint between 0.788 and 1.131 is 0.96, and then 1.307 and 1.546. So as we can see, there's 4 midpoints here, so n has to be 4. Okay, we're going to use 4 rectangles to approximate the area, and we know that delta x is b minus a over n. N is 4, b is 5, a is 1. So we calculate delta x to be 1. So all we have to do now is find the area of each of the rectangles. So I'm going to show you for a couple of these. We find the midpoint between the first 2 points, which we said is about 0.394. So the height would be 0.394. The base, well, the base goes from 1 to 2.2. So the base there is 1.2. So the first calculation will be base times height, which is 1.2 times 0.394. And then we go on to the next one. So we go from 2.2 to 3.1. The base is going to be 0.96, oh, sorry, 0.9, and then the height is 0.96. And so you just keep doing this if you want, or you could just look at the table. So at the table, what I'm doing is subtracting these two numbers. So 3.1 minus 2.2 is 0.9, and then 4.4 minus 3.1 is 1.3, and the height is the midpoint, which is 1.307. And now we need the last rectangle. We go from 4.4 to 5. That's a difference of 0.6 for the base, and then the height is the midpoint, which is 1.546. So after we calculate this, we get 3.962 as our area.